In this lesson, we're going to look at how to put together some compound inequalities from verbal statements. We've got 5 examples here, one of which is a word problem. Our first statement says all real numbers that are less than or equal to -3 and greater than or equal to -8. So the first thing we want to look for is the words and or. In this case we have an and, so we know we're going to have 3 parts. We're going to have something in the front, a sign, something in the middle, a sign, and then something at the back end of it. So what we need to look for is what's going to go in each of those places. We want all the numbers that are smaller than or equal to -3 and greater than or equal to -8. Well, we know our x, which is being represented or representing the all real numbers, goes in the middle. We also know that in a compound inequality, in an and statement, the number that starts should be the smaller of the 2 numbers. Well, our 2 numbers here are -8 and -3. Well, which one of those is smaller? -8 is the smallest, so it should be listed first. -3 is the larger, so it goes at the end. And now our signs. All real numbers that are less than or equal to -3. So we want the numbers x to be smaller than or equal to -3. So we have a less than or equal to sign. And we want them to be greater than or equal to -8. Well, we're actually going to use a less than or equal to sign because this tells us that the x is greater than the -8 because we're opening up to the x, which means it's the larger of the 2 pieces. The next one we're going to look at, we have all real numbers that are greater than 5 or less than or equal to -1. We've got the word or there, which means we're going to have 2 different statements. So the first statement is the stuff that comes before the word or. All real numbers that are greater than 5. All real numbers is our variable x, greater than 5. Or, and now the rest of it is after the word or. Less than, so again we're talking about all real numbers that are less than or equal to -1. So we have x less than or equal to a -1. Now in number 3 here, we have 3 times x is less than -6 and greater than -21. So this one's a little different because we've got something happening to the x rather than just being a single x like we had in the first 2. So we have a 3 times x. We're told that it's an and. So the 3x is going to go in the middle. For our numbers, we have a -6 and a -21. We know the smaller of the 2 needs to be in the front, so that's the -21. The larger is at the back, which is -6. We want our numbers, our 3x, to be less than -6. So we have a less than sign here saying that 3x is smaller. We're pointing at the smaller one. And greater than -21, which means of the -21 and the 3x, the 21 is the smaller. Now this one we would go ahead and solve by dividing everything by 3. So we'd have -7 is less than x is less than -2. Another one we can look at here, 1 less than x is less than -1, or 3 more than x is greater than or equal to 7. Well, this is an or statement, which tells us that, if you remember from our solving the or statements, it's actually 2 different inequality statements, completely separate, that are combined with the word or. So the phrase that's in front of the word or is going to be our first inequality statement. So it says 1 less than x is less than -1. Well, this can be somewhat confusing because we have the word less than twice, but we really only need 1 sign. So how do we know which one is talking about the inequality sign and why is there 2 less thans? Well, this part, 1 less than x, is telling us that we are actually subtracting. We need to take something away from our x. The is less than tells us our sign. So if you remember back in earlier sections, we always looked for that phrase is less than or is greater than to tell us our sign. So in front of our sign we have 1 less than x, which we write as x minus 1, is less than, that's our sign, negative 1. And then we write the word or. Now this after the word or gives us our second inequality. We have 3 more than x is greater than, greater than or equal to, I didn't finish reading, 7. So 3 more than x is 3 plus x is greater than or equal to, that gives us our sign, and a 7. And if we were going to solve this, we would add 1 to both sides here, which gives us x is less than 0. Or, and here we would subtract 3 from both sides, x is greater than or equal to 4. Now let's take a look at an application problem. The high temperature in a city last year was 95 degrees Fahrenheit. The low temperature in that city last year was negative 5 degrees Fahrenheit. Write and graph a compound inequality that represents the temperatures T throughout the year. Well, they're telling us it's a compound inequality, which means it's going to be either an and or an or. We need to figure out which one of those it is. And in this case, they didn't tell us the word and or like we had in these earlier sentences. We need to figure out from what they're talking about if it's an and or an or. Well, we want to write, it says, a compound inequality that represents the temperatures throughout the year. Well, given the information that we're told, we know that the high was 95 and the low was negative 5. And if you think about what you know about temperature, if this was the high and this was the low, that means all of the temperatures throughout the year were somewhere in between. And because they're in between, we know that's going to be an and. In the middle is where we need our variable. They told us to use the variable T to represent the possible temperatures. So we have a T in the center. The high, the big number goes on the right as 95. The smaller number goes on the left as the negative 5. And so we want to have a less than or equal to here, less than or equal to here. We want the or equal to because we were told that the high was 95 and the low was negative 5. So negative 5 and 95 would be included in our possible numbers.